Hello, I'm Tim Cook with Cook Saw Manufacturing, and today I want to show you our PR6 low profile resaw. I'm going to start with how the thing is made. This resaw is made with a band head. What we call a band head is the wheels, the frame that holds the wheels, and the parts, the guides that hold the blade, the tensioner, those kind of things. That's what I call a bandsaw head. What this has is a rigid head that is mounted so that it doesn't move up or down. And then we mount a belt inside that can move up and down. We have adjustments end to end so that we can send it in parallel to how the blade alignment is. And then it can also tilt from side to side. You can also do bevel siding on this. And by the way, we can also put special attachments on this so it makes it a shingle saw or a wedge cutting saw. Either one. So there's many different options you can have with this. I'll show you some of the features about the head that make it really good. Behind this wheel is a drive bearing assembly that we'll show you a little later on, and it's a rigid bearing assembly. We build all the parts in there except for the bearings and the seals, and it's a very rigid. It uses tapered roller bearings just like in your Big Mac truck. But we have a steel wheel. This steel wheel is ground true in relation to this shaft. So we mount this wheel up, grind it true. A true running wheel is what you need on a bandsaw, and that's what we have here. It's very true. While I'm here, you can see we have a drip system that drips onto the blade, keeping the blade clean. We believe in using something like biodiesel or diesel fuel with a little automatic transmission fluid. I'm a firm believer in the transmission fluid because it impregnates the steel and it lubricates, and lubrication keeps things from rusting, number one, but it keeps it from building heat. If we never build heat, then we don't have to cool it. Some people want to put water on like they're cooling it. I don't want to heat it up then cool it. I want to prevent the heat. If I prevent the heat, the saw is cutting much better. In the back side of this wheel, we can tilt this wheel so that the wheel can be tilted to get the right relationship of sawing that we need up here. Another very important feature on this rig. When I go over to the idle side, that's the drive side we call it, and I go over to the idle side, open up the door. We have a bearing inside of this idle side. It's a double row of bearings, heavy duty built. You'll notice these wheels are built heavy duty, very thick on the rim, and so it's got a stationary shaft and this bearing that spins. It makes for a very true running wheel, a very true running shaft. If you'll notice, when I spin that wheel, it coasts very slowly to a stop. If that wheel was out of round any at all, it would come to kind of a locked position. I could roll it back this way and it would spring load back, but when they're very true, you can just roll it and it stops anywhere you want it to. Again, on this side, we have a tilt mechanism so that we can get this wheel in alignment vertically with that wheel so that then it can agree with the cutting bed as we come down through there. And once again, we do have adjustments on that cutting bed so that we can get that relationship correct. That way you get optimum feed speed. On this particular mill, resaw, we put the 1.5 inch blade. So this machine can take actually a 2-inch blade right on down to a 1-inch blade. Generally the 2 inch is not what somebody would want to do here, because that 1.5 inches will outrun the horsepower. You can easily go down to a 1 inch blade and feed it 60 feet a minute with no problem. We have roller guides in here. Again, we've proven these roller guides on our sawmill for many years. For over 25 years we've proved these guides out, and they work very well. If you maintain your blade as we show you, with a sharpening package, a sharpener, setter, and roller, a bandsaw roller, so you keep that blade flat, you'll just saw true lumber all day long, and you'll saw it at high speeds. And that's what you want, something you can depend on, something you can cut accurate lumber. It don't matter if you put hickory in it, white oak, dry wood. Of course, you know, anytime you're sawing dry wood, it's gonna take 4 times as, you know, it'll dull your blade 4 times faster. It's probably 4 times harder. And so you do have to make arrangements for doing that. Your blade will dull out a little quicker, but it'll cut any of those woods. It'll cut hickory, white oak, it don't matter. And of course what we were cutting today was pine. Here is something that's very important to sawing, and we've proved this again for the last 25 years on our AC36 sawmill, and that is the tensioning device. And on the idle side, we have a hinge point right here. We also have a hinge point over here. The hinge point over there is for tracking the blade. I call it opening the book or closing the book. And so the hinge point on the vertical is for tracking the blade. That hinge point, by the way, is also on the drive side, and it makes for easy tracking. It's very easy to track the blade and maintain it. The tension then is hinging this direction. And if I were showing it with my hands, it would be like this. And so we have a spring in here, and when we collapse the spring, it has a handle with an Acme threaded rod, and we loosen up by turning the handle here, tighten up by rotating the handle back tight. And but it's a very forgiving tensioning system that gives and takes. As the blade needs something more, for instance, if the blade heats up and expands, the tensioning device holds it the same. Some of you may have even witnessed some hydraulic tensioners that you always have to keep diddling with. This spring tension system, when you set it, you'll run that blade till it's dull, and then you'll change the blade. So it's a one-time set per time that you put the blade on. And so it's a real simple system, real easy to operate.